In this video, we'll be learning how to set up and solve linear equation word problems. So when working with linear word problems, there are a couple of key things we're going to do in order to make this process easier. First, we're going to define a variable. And remember, a variable is something that is unknown. So it's essentially what we are trying to find. So we're going to start by doing that, and we can pick any variable letter that we would like. The second thing we're going to do is we're going to determine if there is something that is a constant. So this is something that essentially doesn't change. So for example, what this could be is if you ride a taxi and there's a starting fee that doesn't change. You always have to pay $2 to sit in the taxi, and then from there you pay per mile or something like that. So we're going to look for a constant. The next thing we're going to do is we're going to look for what's called a rate, or how something is changing. So this might be, oh, you pay $10 each month, or you pay $4 per book, whatever that might be. So we're going to look for a rate that we might be using that maybe relates to our variable. And then from there, we're going to write our equation and then solve for what the problem is asking us to find. So let's take a look at this example here. It says, the bill to repair your car is $390. I like to make notes as I go, so I know that this is my total bill. It's the total that I'm going to pay. The cost for the part that I need to repair my car is $215. The cost for the labor is $35 per hour. And then lastly, how many hours did the repair take? So the first thing I need to do is define my variables and look for the unknown. The unknown is what we are trying to find. So this final question here helps us to find what we are trying to find, which in this case is what is the unknown. And if we read through this sentence again, what we see is it says how many hours. The number of hours is something that I don't know. So the how many hours is our unknown, and our variable is going to represent the number of hours. Now you can use any variable you like. In this case, I'm going to use the variable h to represent the number of hours. So that's my unknown. I have now defined my variable. Then from here it says to determine if there is a constant. So remember, a constant is something that's not going to change. And when I look at this problem, there are two things I know aren't going to change. I know that I have my total, which is right here, and I have the cost for the part of my car. The cost for the part of my car is always going to stay the same, is always going to be $215. So that's not going to change. I don't need to get multiple parts. I just need that one part in order to fix my car. So I'm going to keep that in mind. Then from here, I'm also looking for a rate, something that has the word per or maybe the word each. And when I look here, this $35 per hour is a rate. So that's something I want to keep in mind. Maybe that's going to use my hours variable because it says per hour there. And so now we're going to use this information to write our equation. Well, it might not seem so obvious right now. Let's think about how your bill at or getting your car repair shop might work. So when I think about going in to get my car repaired, I know that my total bill is going to equal whatever the cost of the part is plus the cost of my labor. Okay? So the total here, we're already given. The total here we know is $390. So let's go ahead and put that right into our equation. Our total is $390. And we know the cost for our part, which is our constant here, is $215. That's not going to change. So I can already kind of start writing my equation. I know my total equals the cost of my part plus the labor. Now, the labor piece here is what I think is the trickiest part, because the labor isn't like a flat rate of $50. Labor is calculated per hour. So we know that we're paying $35 per hour. And so let's say we worked 2 hours, we would have to pay 35 times 2. Say we worked 5 hours, we would have to pay 35 times 5. And so the hours part is what we don't know. That's what's going to vary here, hence why it's a variable. So we're going to use this to help us out. We know that our labor costs $35 times the number of hours that we have, which we're representing by h, since we don't know it. So we've now created this equation of 390 equals 215 plus 35h. And now our final step here is just to solve. So we start by subtracting 215 from each side. So that's going to take us down to 175 is equal to 35h. Then from here, we need to divide each side by 35. So if we take 175 and divide it by 35, we find that h is equal to 5 hours. And the easiest way to check if that's right is to take it and put it back into our scenario. If we take 215 and we add 35 times 5 to it, we do this first, so it would be 215 equals, or plus, 175, and that equals 390, which is where we started. So we can see that our answer of 5 hours is correct. So let's dive into a second example here. The school has a budget of $2,500 to spend on new flooring. The cost of flooring is $10 per square foot. The square footage is determined by multiplying length times width. There is also a cost of $300 for labor to install the floor. If we know the flooring is 40 feet long, how wide can the width of the flooring be and still be within the allotted budget? So first we need to define the variable, and that typically comes from what we are trying to find, which in this case is how wide the flooring is. So I'm going to have W be the width of the floor, which we're going to assume is in feet because the length is in feet as well. So that's what we need to find. Now from here, we need to determine if there is a constant. And when I look at this problem, this 300 right here seems like something that doesn't have a rate attached to it. It just says that it's $300 for installation. So I think that that is my constant, along with this budget item here. We only have $2,500 to spend. Then we also have a rate to keep in mind, which is $10 per square foot. So that's going to be our rate, and I think that's going to maybe have to deal with our variable there. So let's think about this scenario in words and then see if we can put some components of our equation into it. So our total cost is going to be calculated by the cost of our materials added with the cost of our labor. And when I look at this problem, there are two things I know to be consistent. One is that our total is $2,500. And two is that our labor is a consistent $300. So really what I need help calculating in here, or finding an equation or expression for, is the materials. And the materials are calculated by taking $10 per square foot. So we need two components here to make this work. We essentially need to know the area of the room, because that's going to give us how many square feet we have, and then we need to multiply that by the $10 per square foot. So this one requires a little more thinking because we have to think about how we calculate the area of a room. Well, area is calculated by taking length times width. And we know one of these values. We know that length is 40, and we know that our width is our variable here, so we're going to leave that. So really, this component right here can be represented by 40 times W times 10. But that looks a little silly when we have two numbers in there. So we can actually multiply the numbers together and get 400W mixed in there. And that's going to represent the cost of the materials. 400 is the 10 in the cost times the length, which is 40, and the width is something that we still have to calculate. So our equation here is 2,500 is equal to 400 times W plus 300. And now we have an equation that we can solve to help us find the value we were missing at the start. So from here, we need to start by subtracting 300 from each side. So we have 2,200 is equal to 400. And then from here, we need to take 2,200 and divide it by 400. And there we find that our width is 5.5 feet. So what that's telling us is that if we want to get some flooring and our room is 40 feet long, That room can at most be 5.5 feet wide if we want to use this flooring and stay under budget. And let's take a look at a third example here. It says, you and your best friend are going out to eat at Rancho Loco. You have a $10 off coupon that you plan to share with your friend. Since you both ordered the same meal, the waiter gives you one bill to split. After the $10 coupon is applied, the total bill is $36.44. How much did your individual meal cost before the coupon was applied? So this one is a little bit more challenging because it's got a little bit more hidden in there based on how the vocab is written. So let's first start by defining our variable. What we're really looking for in this problem is how much did our meal cost? Now, there's a couple details that if you didn't read carefully might not be so obvious. The first thing is that you and your friend ordered the same meal. So there are two of this same meal. Okay, so they're going to cost the exact same, right? Because they are the same meal. So the cost of these meals is going to be your meal variable times 2. So I'm going to make my meal variable M because I don't know what the meal costs, but I know that it costs M, and I know that I have 2 of them, so I want to multiply them together, which you can write as 2M. So this right here is the cost of the 2 meals before the coupon is applied, okay? What we also know about this scenario is we have a $10 coupon. So we need to think about how we use that in the real world. So if I think this out on paper here, I know that my total cost of my meal, the total that I am going to pay, maybe we shouldn't call it total here, maybe we should call it our cost of our meal. Okay, maybe that's a better way to word it. So our cost of our meal is going to be the cost of the food, or the cost of our 2 meals, minus our coupon, right? Because we are not going to pay full price because we have a coupon. So our cost that they charged us here is $36.44. That's what they charged us. The cost of our food, we don't actually know. We just know there were 2 of them, and they have a cost of M. So we're going to put that here. And then we're going to subtract off our coupon from whatever that is, which is $10. So this is how it's calculated. We have our cost of our food here. We then subtract off our coupon, and then we have what we actually pay for our meal. So let's actually slow this down a smidge, and let's now solve to see if we can find M. So we're going to start by adding 10 to each side, which is now 46.44. And then we're going to divide each side by 2, which leaves us with a meal cost of $23.22. So what this means is that before we applied our coupon, that was the cost of 1 meal. We got 2 of them, and then we subtracted $10 off the price.